Hello guys, my name is Chetan Padiyar.
Hi, this is Kaustubh Boishekar.
Hi, myself Gajanan Palkar.
So basically, our course project is on design of bicycle bell for manufacturing. Aim. The aim of a project is designing and analyzing the bicycle bell of module 0.8 and number of teeth on pinion and gear selected are 17 and 26 respectively. The material selected for pinion and gear are alloy steel and the factor of safety taken is 1.5 and the power required to transmit it is 66.67 kilowatts. The next side is of synthesis. The synthesis basically consists of first, analysis of forces, second, material selection, third, designing of gear and pinion, fourth, dimensions of bicycle bell, fifth, ANSYS of bicycle bell, sixth, detailed drawing. Analysis of forces. The analysis of forces consists of first, plate holder. The plate holder is subjected to TR, known as torsional force, and the lever is subjected to PT and RV, known as tangential force and vertical forces respectively. Next is the gear. The gear is subjected to radial force and tangential force, which is known as PT and PR respectively. The next slide consists of shaft. The shaft is subjected to horizontal reaction force, vertical reaction force, radial force, PR, RV, and also subjected to torque, MT.
Material selection. Material, we are selecting cast iron of grade 35 for gear, pinion and casing, and C40 for lever. The shear strength is 330 megapascal. Hardness is of 207 to 241 HB. The chemical composition is 2.8 to 3.3% of carbon, silicon of 1.2 to 1.7% and manganese of 0.8 to 1.2. Now the gear design. Selection of service factor. For electric motor with normal torque range and medium duty, we are selecting service factor of 1.5, that is taking reference from PSG 7.69. Now design power. So the design power is equals to service factor into power, that is equals to 5 into 1.5 is equals to 7.5 watts. The general layout. The general layout is shown in the figure. For the general assumptions, so tooth profile is of involute, pressure angle is of 20 degree, type of tooth system is full depth, type of gearing is SN gearing. Now the number of teeth on gear as per gear ratio, that is I is equals to 1.53. For alpha is equals to 20 degree, minimum number of teeth required are 17. So Z1 is equals to 17 and Z2 is equals to 26. Calculation of Lewis form factor, which is phi is equal to pi y. Form factor is equals to y is equal to 0.154 minus 0.912 upon z, which is from PSG 8.50. Now y2 is equals to 0.154 is equal minus 0.912 upon 17, that is equals to 0.10035. Now similar for y2, which is 0.154 minus 0.912 upon 26, that is equals to 0.1189. Now capital Y1 is equals to pi into 0.10035 is equals to 0.31526. Now capital Y2 is equals to pi into 0.10867 equals to 0.3763. So the material selection for both the gears, selecting 40 Ni 2Cr 1 Mo 28 case hardened with PSG reference 8.5. So we are getting ultimate stress of 155 kgf per millimeter square, which is 15500 kgf per centimeter square. Now for the endurance limit is 60 kgf per millimeter square, that is equals to 6000 kgf per centimeter square. Endurance limit. The endurance limit in terms of number of cycles are 25 into 10 raised to 3. Now the design contact stress. is equals to 11000 kgf per centimeter square. Now we have to design any one of them because of same material specifications and dimensions, hence designing pinion. Calculation for design bending stress. Now design bending stress is equals to 1.4 kBl upon nk sigma into sigma inverse, in which kBl is equal to life factor for bending, which is 0.7, which is taken from PSG 8.20 table 22. Now K sigma is equals to fillet stress concentration factor, which is 1.2, that is again from 8.19 and table 21 of PSG. And factor of safety, that is N, is equals to 2, that is 8.19 and table 20 of PSG. Now endurance limit is of 6000 kgf per centimeter square, and now sigma bending stress is equals to 1.4 into 0.7 upon 2 into 1.2 into 6000, that is equals to 2450 kgf per centimeter square. Calculation of module based on bending stress, design bending stress. So from PSG 0.13a we get that a module is greater than 1.26 cube root of module design nominal twisting moment transmitted by the pinion, which is in kgf centimeter, and mt is equals to 97420 kilowatt per n, that is equals to 97420 into 0.005 upon 200, that is equals to 2.4355 kgf centimeter, and mt is equals to mt into kdk into k. Now kdk is equals to 1.3, that is from reference PSG 8.15. mt is equals to 1.3 into 2.4335, that is equals to 3.16615 kgf centimeter, and psi m is equals to b by m is equals to range, that is from PSG 14 and table 12, that is m. So module is greater than equal to 1.26 cube root of 3.16615 upon 0.10035 into 2450 into 10 into 17, that is equals to 0.056. Now selecting module m is equal to 0.8 mm, that is equals to 0.08 centimeter, which is from PSG 8.2. Calculation for now induced contact stresses. So induced contact stresses is equal to 0.74 I plus minus 1 upon A under root of I plus minus 1 upon A into E into MT, which is from PSG 8.13, and gear ratio is 1.53. So A is equals to center distance of two gears with respect to rotational centers. So that is equals to 2 into E plus m into z1 plus z2 upon 2. So that is equals to 2 into 0.7 plus 0.8 into 17 plus 26 bracket close upon 2, that is equal to 109 mm, that is 1.854 centimeter. Now b is equal to psi m into m, which is equal to 0.8 centimeter, and e is equal to 2.15 into 10 raised to 6 kgf per centimeter square, which is from PSG 8.14. Hence sigma C induced is equal to 0.74 1 plus 1.53 upon 1.854 under root of 1 plus 1.53 upon 1.854 into 2.5 into 10 raised to 6 into 2638.45, that is equals to 904.297 kgf per centimeter square. It's clear that sigma C induced is less than sigma C design, so pinion is safe in contact stresses.
Checking for dynamic load using Barth velocity factor. Calculating beam strength, Fs is equal to design bending stress into B into Y into M, which is from PSG 8.50. Now Fs is equals to 2450 into 4 into 0.3768 into 0.08, that is equals to 153.7288 kgf. Calculation for dynamic load. Vm is equals to pi dn upon 60 into 1000, that is equals to pi into 6 into 17 into 200 upon 60 into 1000. Now Cv is equal to 6 plus Vm upon 6 equals to 6 plus 0.0667 upon 6 equals to 1.1778. Now dynamic load Fd is equal to Ft into Cv, that is PSG 8.50. Now Ft is equals to 2 mt upon d1, that is equals to 2 into 2.4355 upon 0.08 into 17, that is equals to 3.578 kgf from taking PSG 8.57. Now Fd is equals to 3.5786 into 1.845 equals to 4.242 kgf. Now since Fd is less than Fs, hence gear is safe in dynamic loading. So now checking for wear load. Wear load Fw is equal to dq kb from PSG 8.51. Now d is equals to 0.08 into 17, that is equals to 1.36 centimeter. Now q is equals to 2i upon I plus 1 equals to 2 plus 1.53 plus 1 equals to 0.7905. Now k is equals to sigma square c sin alpha, that of 1 upon e1 plus 1 upon e2, that is upon 1.4 equals to 11,100 square into sin 20 into 1 upon 2.15 into 10 raised to 6 plus 1 upon 2.15 into 10 raised to 6 bracket close upon 1.54, and that whole equals to 27.497. Now Fd is equals to 1.36 into 1 into 27.4979 into 6, that is equals to 211.875 kgf, and it is clear that Fw is less than Fs, so hence gear is safe in pitting failure. Now gear tooth proportion. Module M is equal to 0.8 mm, center distance A is equal to 18.5 mm, height factor is equal to Fo is equal to 1, bottom clearance C is equal to 0.25 meter is equal to 0.2 mm, tooth depth H is equal to 2.25 meter equals to 1.8 mm, pitch diameter D1 is equal to mz equal to 0.8 into 17, that equal to 13.6 mm, and D2 is equals to mz is equals to 0.8 into 26, that is equals to 20.8 mm. Now tip diameter DA1 is equals to DA2 is equal to Z plus 2 FO into M equals to 17 plus 2 into 1 into 0.8 is equals to 15.2 mm, and DA2 is equals to 22.4 mm. Now root diameter is DF1 is equal to DF2 equals to Z minus 2 FO into M minus 2C, that equal to 17 minus 2 into 1 into 0.8 minus 2 into 0.2 is equals to 11.6 mm. DF2 is equal to 188. Now testing. So we have done testing on axis of gear and pinion in bone measure stress analysis, stress strain analysis, also the toothed lever. The figures are shown on of the gears and pinion. In figure 1, that is shown the where the minimum similar, that blue indicates the minimum deformation, and where the red portion indicates the maximum deformation on the gear and pinion. On figure B, static structural, which is equivalent elastic strain, in same the green portion indicates that there is minimum strain and the red portion slide indicates the maximum strain. Now in toothed lever, the toothed lever in which the red portion is also considering where the maximum elastic strain is acting, and in green and the blue portion have minimum elastic strain. Also the equivalent bone measure stress that is shown in gear tooth lever is shown in the blue and various colors, so that whereas we have get bone measure stress. Now the static structural total deformation, which is shown on gear tooth lever again. Now the detailed drawing that is shown in the figure. Thank you.